Hey guys, my name is Vijay and welcome to the tutorial of basic types in Kotlin. So in previous tutorial we talked about how to get started with Kotlin and how to compile and all those kind of things. In this video we are going to talk about some primitive types in Kotlin. Now before I start programming and everything, let me just tell you one thing. Everything in Kotlin is an object of some class. Okay, so the basic class, like in Java it's object, right, which is the base class of everything else. In Kotlin, any is actually a base class of anything. So for example, let's just say that I'm just going to create a main function. I just say one variable name which should be any, and then you can literally define put any value inside of this, where it's name or this, or I don't know, 4.5 floating, anything. So this is like the base class. On top of that, all the class are built. Okay, so the concept of interfaces and all those kind of things will come in the when it'll come, I'll tell you in detail and how all this type system works in Kotlin. But for now you just need to remember that everything in the Kotlin is an object of some type or some class. Okay, so now there are some special types which Kotlin has defined internally. They are called primitive types. So let's go through the primitive types. So we have 5 sets of primitive types, basically for numbers, for characters, for string, sorry, I just gotta put character, string, and boolean, and some collection type. Basic is array. Okay, array is basic. So all other collection types like linked list or map, hash map, set, all those collection types will be coming in the separate dedicated video, so don't worry about that. Let's go through the number. Okay, so numbers are based on the size of the storage, okay, the memory that it contains, it occupies. So let's just create a one variable, very small, 8-bit. Okay, it's called in Kotlin byte is equal to 1. Now byte is nothing but a number with 8 bits. Okay, so I'm just going to write down size also 8-bit. So whenever you create any type, any variable where the type is byte, it's gonna occupy 8-bit in your RAM. So remember that. This is really important. For example, so the range of this, it can so number, if you wanna store, you can store 1 to 255. That's it. So this is like their limitation. Okay, something like that. Or if it's unsigned or signed, then you can just do -127 to 127, 128, something like that. But for simplicity, I'm just giving you the size. Okay, sorry. Another type is called short, of type short, which is again, I'm just gonna 20. The size is 16 bits. Okay, sorry for that. So now what happens is, what if you have some number that you don't want above certain range, for example like 32,000, right? Then you can actually create short instead of some bigger type and save some space. The third type is I'm gonna call int, which is int capital, which is any number, let's call it 100. Now the size here is 32 bits. Now why the size matters, you seeing, right? For example, now you need some number which possible value is from 1 to 255. Then you don't need to specify int, that type as int. You can specify as a byte and you can work with it. Why? Because it's gonna just take 8 bits instead of 32 bits. So you are actually optimizing for 4x, 4x size of your RAM. This is how sort of like optimizations are done. If you see, right, these are like the micro optimizations, but these are really important when you have some large project and requires a lot of memories, right? Another type is long, which is anything which size is 64 bits. So this is like the maximum you will be going. So if you have like very big number in billions or something, then you can assign long and you can be done with it. So now the by default whenever you create a number, for example if you do variable number of 300, right, then it's going to create with int. So that's why if you see the error here, right, explicitly given type is redundant, because by default whenever you give a compiler and a capacity to or permission to define any type, and you are not specifying any type, it's going to go for the int, which is 32 bits in memory. So if you want something other than int, and then you have to explicitly specify. For example, if you want like big number, you have to explicitly specify that this is a long and I don't want int. These are like the integer number types without any floating points. Now let's see how to create a float. Float is type float is equal to 3.4. Now remember one thing, if float is a 32-bit in size, now it's showing error, right? Why? Because whenever you define or create a float in value, you have to end it with f, then only it will be considered as a float, otherwise it will be considered as double, which is another and last type. So as you can see, now double is a very it occupies 64 bits of space, and this will occupy 32 bits of space. So if you have a floating point number and you don't want to you want to optimize, and you don't want to push a lot of memory, then you can just create 3.4f and it will take care of your 32 bit will be taken care of. So these are the primitive number types when it comes to Kotlin. These are like the basic types. You can create many you can create many composite types by merge and mix all these numbers and everything. Not an issue. We will be going towards that, and we'll be seeing how to create custom data types and everything, so don't worry about that. These are just a class, they are not data types. One thing to note in here is all those types are capitalized, right? So the first letter is capital. So this is like the standard way of doing in the Kotlin. You have to capitalize your types and everything. So whenever you're creating any class or anything, you have to put a capital, start with the capital. This is I think it's forced into you. So whenever you might be creating a class, then you might have to specify. When the class tutorial will come, we'll see more in detail, don't worry about that, but just remember that all the types are capitalized. Let's create a character type. So we'll create a character type. So character type is defined by char is equal to r. So this is our character type. It's gonna occupy 8 or 16 bits. Based on if it's ANSI, then it's gonna be like 16 bit. I think all languages support ANSI, so it's gonna be like 16 bit, but it's ASCII coded, then it's gonna be 8 bits. So now remember the character type in other languages, if you see, it's just a byte most of the time, but here it is not a byte. So you cannot just give some number and it's gonna work. No, you have to specify in the single quotation that this is a character. Let's create a string name string is equal to, string is easy, right? In double quotation you just say my name is Vijay. This is how you create string. Now let's create a boolean. Now booleans are very small types, just true or false, you might be knowing. So true or false is a boolean. I'm just gonna get true. You can also give value false or something. Here again you see it's redundant, right? Why? Because Kotlin knows that it can be boolean because it's a true or false, right? So it have to be boolean only. Here string also they're saying it's redundant, you don't need to write, but I suggest you write it down. See, it looks really good. Plus the name is string now, character is a char now. So these are all the types. The last type is actually not a type, it's sort of like a container for different kind of types. It's like array. but I consider is as a like a primitive types, because you need to understand that. Okay, so let's see how array is defined. So there are a few ways you can define, but couple of ways I like to define array is when it comes to Kotlin. So one of the type is there is an inbuilt function called array of that you can do. Okay, let's see how it works. So I'm just creating array of items. The type is okay. Yeah. So the basic type is array. Okay, and here you have to do, this is a kind of a generic type. We will be talking more about that, but for now just remember that whenever you want to define an array, now remember array are of a single type, right? A collection of single type or single values of some particular type. So I'm just going to create array of integer, okay, is equal to array of, then you just can give the value 1 2 3 4 5 6 7 8 9 10, whatever, right? So you can give them. This is how you create a type of array. Okay, so now this is like the one way to do array. Other way to do is other items is again array of integer. Is array construct, so this is like construct where you specify the size in integer, which is I just said 10, and you specify closure functions, where first argument is the index, and the only argument is index and I into 2. I'm just going to specify this. Okay, so now what is happening in here is this is a kind of like closure function, okay, or lambda function that we will be talking about in future tutorials. Don't worry about that. Just remember for now that here what it means in array construct is first variable is how many element you want in this array, fixed size, okay, and other is like just like producing the variables or those 10 elements. So what happens is when you call this when you create this, right, this function will be called number of times, which is I, the size, okay, and this is like the index. I is here is the index, so it will be called for particular position. You can actually generate that particular value for that position and it will push into that. This is kind of like a functional programming paradigm. I told you, right, when I started, Kotlin is also kind of functional also. This is really important. We will be seeing these use cases and all the advantages of writing closures and all those kind of things in future tutorials, when we will be giving closure a bit of like functional touch and everything. So for now we just have to remember this is a closure. It's nothing, it's a function. It takes index as argument, and whatever you are returning, right, it will actually push into that particular index. Okay, now now what happening is, okay, now you might be like, how to access the items? It's simple, where particular item is of type integer from items. So like you can just write it down index from 1, give me, this is one way to do, or you can just call a get method on item and just specify that index and you will be getting it, right? How to set, if you want to set some items dot, there is a function called set, and you can just specify on first index I want to update this to 40 and it will update it. Okay, so you don't have to worry about that. And also you can do items dot 1 is equal to 40, the traditional way of doing it. That will also work, you don't have to worry about that. But just make sure that this index, this can throw an exception if the size is like right now 10 and you just specify like 30 or 30 or 40, right? This should not, it will throw a runtime exception. Why? Because at compile time this Kotlin won't know what size you have specified. So when you will run, because it's 40, so it can throw an out of bound array out of bound exception. So make sure about that. So this is how we do array kind of thing. Okay, looping over array and all those kind of things, I think maybe so the next tutorial is it will be about control flow and everything, and after that I'll be talking about a lot of looping related things. At that time I might be telling how to loop through array and everything, so don't worry about that. So this was all different primitive types in Kotlin. So I think this is it. You just need to remember, this is really important. You might be thinking why, and this type. No, whenever you are doing the optimizations, or whenever you want to save some memory or something, so just make sure that you you have all these types in mind. So whenever you creating the variable, you just don't waste unnecessary RAM or something by, if you need just a byte and you are specifying long, then it's like you are actually 64 bits instead of 8 bits, you are actually allocating to that particular variable, which is can be costly. So yeah, so these are all primitive types. Okay guys, so I'll see you on next tutorial, and we'll talk about control flows, how if else work, how conditioning works, and all those kind of things. So thank you.